Is concept of specific humidity and relative humidity is confusing to you? In this video, we will solve a very simple but very conceptual numerical to calculate specific humidity in grams per kg of dry air using given relative humidity and given ambient conditions. As given here, we have ambient pressure, temperature, relative humidity at a particular location given to us. The saturation pressure of water vapor is also given to us. So let's first write down the given data. So we have ambient pressure given to us, which is 101 kilopascal. Ambient temperature is 300 Kelvin, and relative humidity is equal to 60%. At 300 Kelvin, saturation pressure is given to us, which is equal to 3.6 kilopascal, and we are calculating specific humidity. So the specific humidity is defined as mass of water vapor present in a unit mass of dry air. So it is the ratio of mass of water vapor per unit mass of dry air, and its unit is kg of water vapor divided by kg of dry air. Specific humidity can also be written in terms of partial pressure and total pressure. So it is equal to 0.622 multiplied by PV divided by PT minus PV, where PV is partial pressure of water vapor and PT is total pressure. And in this case, this total pressure is ambient pressure or atmospheric pressure given. For this numerical problem, we cannot use this first equation of specific humidity because there are two unknowns, mass of water vapor and mass of dry air. But we can use this second equation of specific humidity where total pressure is given to us, which is ambient pressure. If we calculate PV here, we can easily calculate specific humidity. In order to calculate PV, we can use relative humidity, which is already given to us. So the relative humidity is the ratio of the actual mass of water vapor present in a given sample of moist air to the maximum amount of water vapor present in that same air when that air is saturated. Relative humidity can also be written in terms of ratio of pressures. It is the ratio of partial pressure of water vapor to the saturation pressure, and both these pressures corresponds to same temperature. So in this case it is 300 Kelvin ambient temperature. So here we will use relative humidity to calculate PV first, and from PV we can calculate specific humidity. So the relative humidity is PV divided by P saturation, where relative humidity is already given to us. P saturation at 300 Kelvin is already given to us. I can also write this PV is equal to relative humidity multiplied by P saturation. How much is relative humidity? Is 60%, which is equal to 0.6 multiplied by what is saturation pressure. Saturation pressure at 300 Kelvin is 3.6 kilopascal. So 0.6 multiplied by 3.6 kilopascal. So we will get PV is equal to 2.16 kilopascal. So partial pressure of water vapor is 2.16 kilopascal. So now we have PV is equal to 2.16 kilopascal. We already know that total pressure or ambient pressure is 101 kilopascal. So we can calculate specific humidity now. So omega equal to 0.622 multiplied by PV, which is 2.16 kilopascal, divided by ambient pressure 101 kilopascal, 101 kilopascal minus PV, which is 2.16. So we will get specific humidity equal to 0.01358 kg per kg of dry air. So this is the specific humidity in kg per kg of dry air. So the calculated specific humidity is in kg per kg of dry air. And the question is asking that to calculate specific humidity in terms of grams per kg of dry air. So if we want in terms of grams per kg of dry air, we can write it as specific humidity is equal to 0.01358 multiplied by, instead of kg I can write 1 kg is 10 raised to 3 grams, so I will write 10 raised to 3 grams divided by per kg of dry air. So from this we can get, multiply this 10 raised to 3 with 0.01358, specific humidity is equal to 13.58 grams per kg of dry air. So specific humidity is 13.58 grams per kg of dry air.